Okay, thank you, Salva. Okay, and then, all right, so the specific latent heat of fusion. Okay, so again, before this heat capacity and the specific capacity, the difference is the 1 kg. They give you the amount of substance, okay? So that means must have 1 kg, okay? Same also as the specific heat, latent heat also. Is the meaning is the same, but just add 1 kg. So means here the heat absorbed, okay, or release, okay? If you want, the amount of heat absorbed or release, okay, for 1 kg of substance, okay, to change its physical state, okay, with the constant temperature. Okay, so that is the meaning of the specific latent heat. Okay, specific latent heat of fusion. So fusion means from solid to liquid or from liquid to solid. So the heat absorbed when 1 kg of solid change to liquid, okay, or heat release when the liquid change into solid at constant temperature. Okay, so the difference here only they have the 1 kg here. Okay, and then for the specific latent heat of vaporization, okay, so the heat absorbed when 1 kg liquid change to vapor or heat release when vapor change into liquid at constant temperature. Same, okay, but only you add 1 kg here. So let's say they ask you about the specific latent heat, so you must know must have a 1 kg and then what state does it change, whether to from solid to liquid or liquid to gas, okay, or and then another one must have the constant temperature here, right? So the unit of latent heat is J kg negative 1, okay. So this is the for specific latent heat. Okay, and then when temperature remains constant, okay, the kinetic energy of molecule remains constant. So what's the energy? Where's the energy go? So the energy used to overcome the forces of attraction between the molecule. Okay. So next one is the heating curve. Okay. So this one, of course, solid. Okay. So this one solid plus liquid. This one is liquid. This one is liquid and gas. So this one is gas. Okay. So you know here, when for latent heat, there is no temperature change. So this one, okay, solid to liquid. So this one is called as the latent heat of fission. This one is liquid and gas. So it's called as latent heat of vaporization. Okay. So the formula, okay, for here, usually we use the Q is equals to ml. So this one is for specific latent heat. Q is equals to ml. So Q is the quantity heat, right, for specific latent heat, okay, equals to M is mass. Okay, L is the latent heat, okay, the value of the latent heat for the substance. Usually L is the constant value, means the question will give you, okay. So this one is the heating curve, okay. And then this one, so this one you can see the temperature is rising, right? So means this one, if you want to calculate the quantity of heat, this one use the Q is equals to MC theta. This one is Q is equals to ml. This one is Q is equals to MC theta. This one is Q is equals to ml. So again, this one is Q equals to MC theta. Okay, so this is the graph. Right, and then goes to the gas law. So there are 3 gas law. Okay, Boyle's law, Charles law, and Precious law. So the first one is a Boyle's law. So Boyle's law said the P is inversely proportional with the V. Okay, means when the pressure increase, okay, the volume will be decreased. Okay, so the Boyle's law state that for a fixed mass of gas, the pressure of gas is inversely proportional to its volume. Okay, so the formula, okay, so this is the formula. P1 V1 is equals to P2 V2. Okay, so this one is the graph. Okay, so this is inversely proportional. But when you draw a graph P against 1 over V, that will become directly proportional. Okay, so you have to remember the graph and also the formula and how to use it. Okay, and then the next one is Charles' law. So Charles' law said the V is directly proportional to T. Okay, so this is the formula. V1 over T1 is equal to V2 over T2. Okay, so the temperature here must be in Kelvin. So you have to change, okay, from degree Celsius to Kelvin. Okay, just add 273 here. Okay, so later in the question, we will try to do how we will try to use this formula. Okay. Alright, and then the graph. Okay, so the graph is the axis is in the in Kelvin. Okay, the unit is in Kelvin. The graph should be directly proportional. Okay, but let's say the graph is the x-axis in degrees Celsius. Okay, so it will be increasing linearly. But when you expand the graph here, so it will reach until the x-axis here. So this point is called as the absolute temperature. Okay, so absolute temperature means negative 273. So what happened to the kinetic molecule? Okay, kinetic energy of the molecule, okay, at this point, so it almost zero, means the atom almost cannot move. Okay, so this is the graph for the Charles law. Okay, and then the next one is a Pressure's law. So Pressure's law said the pressure of gas is directly proportional to the absolute temperature, means the pressure is directly proportional to the temperature. Okay, so this is the formula. So T must be in Kelvin again. Okay, and you have to change it. Okay, so this is the graph. Is the Kelvin must directly proportional in degrees Celsius. Okay, when you try to expand the graph, it will goes, okay, until the point here at the x-axis. So this one is again called as absolute temperature. Okay, and then this one, the molecule is almost cannot move. Okay, so the kinetic energy almost zero here. Okay, so that is the chapter 4. Okay, so what you need to know, okay, for chapter 4. Alright, so I gave you a question before, right? So this is actually paper 1. Okay. Can you try to answer first number 1 until number 4? Okay, I give you like maybe 3 minutes. Okay, so then we try to discuss the answer. Okay, so let's go to the first question, right? So the diagram shows two copper blocks, okay, L and M, touching each other. So the initial temperature of the L and M are 50 degrees and 30 degrees Celsius, okay? So which statement is correct when L and M at the thermal equilibrium? So I told you already, you have to find the three sentence. The first one, okay, temperature is same. The next one is no net heat flows between two objects. Okay, and then another one is the rate of transfer between two objects is same. Okay, so the answer should be D donkey, right? Number two, okay. Diagram 12 shows a metal sphere at temperature of 90 degrees, okay, immersed in the liquid at temperature 40. Okay, so what is the final temperature when the thermal equilibrium is achieved? Okay, so it should be between 40 and 90. So the answer is D donkey. Okay, for number 3, right? So diagram 11 shows hot water being added to cold water. So which of the following statement is correct if there are no heat loss to the surrounding? Okay, so the first one should be, the answer should be C. Okay, the heat loss should be equals to the heat gain. Okay, so the answer is C. Right, number 4, what is the concept used in the measurement of human body temperature as using a thermometer? So this one using the thermal equilibrium, right? So this one sometimes come out for the essay part, right? Before this, remember the doctor put the thermometer, okay, under the tongue of the patients, right? And then the heat energy from the body patient transfer to the thermometer, right, until it reach thermal equilibrium, means the temperature of the thermometer is same as the temperature of the patient. So this one quite famous for the application questions, the 4 marks question. Right, and then number 5 until number 6. Okay, this one I give you 2 minutes, okay, to answer. Okay, I know before this I discussed chapter 2, right, in the online class, okay, but we already now started in the class, okay, we discussed chapter 2 also, right, so I don't want to do the same thing twice, right? So after that, I finished the chapter 2 we discussed, that we discussed by topic. Then I will use that question, okay, to answer in the class. Okay, after we finish completed the chapter 2 discussion, the paper I gave. And the paper I gave is actually not a full chapter 2 until I think 2.3 or 2.4. Okay, I get another set because chapter 2 is 12 topics, right? So it's quite long. So I make it part by part. So the one that you get is actually the chapter 2 part 1. So there will be like I think 3 part or 4 part. Okay. So later after I finish the 4 parts for chapter 2, then we discuss the question that I gave before. Okay. So this one we just continue. Then maybe after this chapter 5 online, okay? Okay, let's see number 5, right? So it says here, diagram 12.1 shows hot water being put into the cold syrup. So diagram 12.2 shows the final mixture, okay? So which statement is correct about the temperature of the final mixture, okay? So it should be is higher, is lower than the temperature of the hot water. The answer is B, boy. Okay. And then number 6, okay, the diagram shows 4 types of metal block of the same mass being heated within the same quantity of heat for 10 minutes. Okay, so the question asks which one has the highest increase in temperature. So highest increase in temperature means must have the low specific heat capacity. So the lowest one should be A. Okay, 235. Okay. Okay, number 7 until number 11, I give you like 4 minutes, okay, to calculate, okay, to find the answer. If you have any question, you can open your mic, okay, because I will not see the chat there. In case your friend cannot open the document, so they can refer here at my laptop, okay. So if you have any question, just open your mic and ask. Okay. So the first one is what happens when the coffee and the cup are in the thermal equilibrium. So the answer is C. Okay, there is no heat flows. Okay, number 8, water is suitable to be used as a cooling agent because of its high heat capacity, mean it can absorb more heat. Okay, so it is need a lot of heat, okay, to increase the temperature of water. Okay, so number 9, water is used in the cooling system in car engine. So why is water used as the cooling agent? Of course, because the water can absorb a lot of heat. So the answer is D. Right, number 10, okay. So 7,600 joule of heat is used to increase the temperature of 800 gram metal blocks from 30 to 55 degrees, okay. So this one we use the formula, right? Q is equals to MC theta, okay. So the mass here is 800 gram, right? So you change to kg, okay. And then C you need to find. Okay, theta is 30 to 55. Okay, means the increase the temperature is 25. Okay, 55 minus 30. And then the amount of heat Q, the quantity of heat is 17,600. Okay, so you count, you got 880. Okay, so the answer is D, donkey. Okay, in a laboratory, water boils at 100 degrees Celsius. What happened to the boiling point when sugar is added to the water? So of course it will be increased. Okay, so the answer is A. Alright, the next one, number 12 until number 13. So I give you 2 minutes. Okay, number 12, right? The specific heat capacity of aluminium is 900 joule kg negative 1 degree Celsius negative 1. So which statement explains the specific heat capacity of aluminium correctly? So means the answer here is B. Okay, so the temperature of 1 kg of aluminium will rise by 1 degree Celsius when it absorbs 900 joule of heat energy. So the answer is B, boy. Right, number 13. Okay, so diagram 17 shows a lead block, an iron block, and aluminium block. So all the block have the same mass and heated with the same amount of heat energy in 15 minutes. Okay, but the difference here is the specific capacity. So you can see here the lead block is 230, iron block is 460, aluminium is 910. So means the lead block has the lowest specific capacity, means this one will heat up faster. Okay, and then this one should be the lowest temperature. Okay, so which statement is correct at the end of the 15 minutes? Okay, A, the lead block has the lowest final temperature. Okay, wrong, because this one lowest specific capacity heat, right? So that means this one has the highest temperature. Okay, the aluminium block has the highest. No, okay, because this one is the highest specific capacity. So the temperature should be the lowest one, right? And then the final temperature of iron block is equal to aluminium block. No, because they have a different specific capacity. And then the last one, the final temperature of the lead block is higher than iron block. So the answer is D. Okay, of course, because the lead block has the lowest, right, specific capacity. Okay, so this one will increase the temperature increase. Okay, very high. Alright, number 14 until number 16, okay? 3 minutes. Okay, because this one is very simple question, I think. Right, so I hope you already finished. Okay. So the graph shows the heating curve of substance, right? So at which stage is the substance in the liquid and gases at the same time? So liquid and gases means change of physical state, right? So when change of physical state means should be latent heat. Okay. So in the graph, latent heat means the one that the temperature is not increased, doesn't have any change in temperature. So whether it's QR or ST. Okay. So liquid and gas, this one is solid and liquid. So liquid and gas is ST. So the answer should be D. Right, number 15, right? Number 15. So diagram 13 shows the cooling curve of a substance. Okay, so which stages are specific latent heat release? Okay, so specific latent heat, always remember no change in temperature. So you should choose the one that is constant. So Wx and Yz. So the answer is B, boy. Right, number 16, okay, so the graph shows the heating curve of substance. Which of the phases labeled A, B, C, D shows the heat is absorbed during melting process. So melting process means solid change to liquid, okay, so means latent heat. So solid change to liquid, so this one. So the answer should be B, boy. Okay, right, number 17, 18, and 19.
Teacher,
Yes.
why isn't 16A?
16, 16, this one. I said the answer is A. The answer is B, sorry. The answer is B.
No, I mean, why is it B?
Your voice is not so clear.
Isn't heat absorbed like the temperature increases?
Yeah? Okay.
So shouldn't it be A?
Should it be A, melting process? Melting process is actually from solid to liquid, right? So if the change of phase, so means should be latent heat. Okay, if solid here, this one is there is no change of state here, right? So the melting process involves the change of state from solid to liquid. So you must choose this one, solid and liquid, because melting means there is involvement of the change of physical state from solid to liquid.
Okay, okay.
Okay, right. Stop at number. Okay, goes to number 17 here. So diagram 12 is a graph which shows the heating curve of water. So what is the effect of the heat absorbed by the water between point S and T? So the answer should be B. Okay, it breaks the bond between the water molecule. So that one. Alright, number 18. Okay, so the naphthalene which starts to melt at the time of T1, okay, because at T2, okay, this one the solid already changed, okay, 100% to liquid, okay, starting for T2, so it start to melt at T1. Okay, number 19, it said in which process A, B, C or D is a latent heat of vaporization. So vaporization means from liquid to gas, okay? And then or gas to liquid also can. Okay, but it says here absorb. So mean absorb means the answer should be B. Okay, number 19. So this one is latent heat of fusion, okay, from solid to liquid. So this one will be absorb. The A, the latent heat of vaporization is absorb. Okay, sorry, the latent heat of fusion is absorb. The latent heat of fusion being released. Okay, and then this one latent heat of vaporization is absorbed. The latent heat of vaporization is released. Okay, for C. Okay, number 20 until number 24. Okay, let's see number 20. Okay, so what occurs during the melting of naphthalene? Okay, so melting means there is no change of temperature and it's a specific latent heat of fusion. Okay, so the temperature of naphthalene does not increase. So it must be at a constant temperature. So number 20, the answer is B, boy. Right. Number 21, the latent heat of fission for water is heat absorbed by 1 kg of ice during melting without changes in temperature. The answer is A. Alright, number 22. Okay, so this one is a calculation. So we read the question first. The air pressure in a car tire is 200 kilopascal at the temperature of 25 degrees Celsius. So what is the air pressure in the tire at the temperature of 37? So pressure and temperature, so this one means the pressure's law. So P1 divided by T1 is equals to P2 divided by T2. Okay, so the P1 is the P1 is 200 kilopascal. Okay, and the temperature is 25. Okay, so 200. Okay, then we change the temperature to Kelvin. So 298 plus 273. Okay, and then the P2 then you need to find. Okay, and then the temperature here 37, right? So 273 plus 37 is 310. Okay, then you calculate, you got the answer. Okay, you got the answer D. Okay, 22 is D, 208 kilopascal. Okay, number 23. Which of the following graph shows the relationship between P and T at the constant value? So you see the axis here is Kelvin, right? So Kelvin must directly proportional. If the axis is degrees Celsius, then the graph should be like this. Okay? If the axis is x-axis is degrees Celsius. Okay, number 24, right? The diagram 13 shows the condition of the plastic bottle which initially contains hot air before and after being put into a basin of ice. So the above situation can be explained by the Charles law. Okay, I know Precious law is also correct, right? Because this one has a highest pressure, right? So this one, but you have to see the they use here the volume, the change of volume here. Okay, so volume and temperature, of course, is Charles law. Okay, so the answer should be C. Alright, 25 until 27.
One use Yinghui and Jingwen as Y17A is wrong.
Oh, which one? Wait. Number
17.
17. A is strong. It weakened the forces between the water molecule. Okay. Because this one changed from gas to liquid, right? So if you want to, there is a bones, right, between the. Wait, right? I draw for you. Okay, so this is the liquid, right? So if you want to change it to gas, right? So the distance is much further. So you need to break the bone. Okay, so to free the molecules, so it can be in the gas state. Is it okay? I think my earphone got problem. I cannot hear you well sometimes. Is it okay, Yuhui? Then what does the force between water molecule means? Force between water molecule. Okay, this one only weaken the force. right? But it's not break the bones. It just weaken the force between the water molecules. Okay, if you want to make it to the gas state, right, you have to break the bones. So the so it will become in the gas state. It just weak the force, but it does not break the bond of the between the molecules. So means it's still in the solid state, right? Sorry, it's still in the liquid state. Okay, it's not in the gas state. If you want to if you want to make to become it to you want to change it to the gas, you have to break the bond of the molecule so it can be free and become the gas state. It only weaken the force, not break the bond. If you want to form the gas state, you have to break the bond of the molecule. Then the molecule will become free. Then it can become the gas state. Is it okay? All right. So this is the last one, I think. Okay, the Boyle's law states that PV is equals to constant. Okay, so which graph represent the equation? So the answer should be A. Okay, P is directly proportional to 1 over V. Alright, number 26, alright. So a fixed mass of gas in container of fixed volume is heated. Okay, so which statement is correct? Okay, so the answer should be D. Okay, the kinetic energy will be increased means the gas molecule move with high velocity. So 26 is D. Alright, 27. Which of the following explains this situation? So this one is a border gauge. Of course, it's measure the pressure. So this one is a shrink. So this one is actually the volume. Okay, so P and V is a Boyle's law. 27 is A. Alright. Can we just go number 28, 29, and 30? So I just discuss, okay? Right, number 28, diagram 30 shows the apparatus used to investigate the relationship between the length and the temperature. Okay, so temperature, and then it said which graph represent the relationship between L and T. So this one you have to know which gas law is it, whether the Boyle's law, Charles law, or Precious law. Okay, so this one of course it been heated, right? So temperature means there must be like between pressures of Charles law. Okay, Boyle's law cannot because Boyle's law is pressure and volume. Okay, and then the trapped air is actually represent the volume here. So volume and temperature, this one is actually Charles law. Okay, so Charles law, and then the temperature is in degrees Celsius. So you can see here the answer is D donkey. Right, number 29. Okay. Diagram 15 shows the pressure temperature graph for a fixed mass of gas at constant volume. Okay. What's the question? Okay, this one is the question. Which statement is correct about the condition of the gas? Okay, so the gas pressure is 0 at 0 degrees Celsius. Okay, so the gas pressure is 0 at degrees Celsius. So this one, 0, no. Okay, still have a value here. Okay, and then the gas molecules are stationary at negative 273. So this one the answer is B. Okay, because this one the kinetic energy almost zero. The molecule cannot move. Okay. So the answer is B boy. Okay, so I stop until here, right? So if you have a time, maybe you can continue, okay, until page 18. Okay, and then the next week class, I will discuss the paper 1. Okay, and then we try to see paper 2 also. Okay, for chapter 4, right? So I will give you the chapter 2 later, okay, in the group. So if you have time, you can try to answer first. If not, we can discuss in the online class. Okay. So any questions? Okay, thank you. See you on Monday. Okay, welcome.